Now that we are done with triangles, next we look at parallelogram and rectangles. We are taking these two side by side because a rectangle is a special parallelogram. They have very similar properties, just with the in case of a rectangle, all the angles are what? 90 degrees. Apart from that, they both have opposite angles being equal, opposite sides parallel and equal. What is the perimeter of a parallelogram? As we saw earlier on in the triangle, the perimeter of an object is simply its total boundary length. So looking at the parallelogram, you will agree with me that the perimeter of this parallelogram, let me just represent it with P, will be equal to, starting from length B, and I go up, A plus B plus A. And you will agree this will be what? 2B plus 2A. Just add up the entire length. Of course, I can factorize 2 out, and I have here A plus B. If you like, you can write it as B plus A. Similarly, that's it there, and well stated. For the rectangle, what will be the perimeter? We all know this, right from nursery 1, I did this. The perimeter of a rectangle, again, I use P to represent, is the total boundary length. So I'll take the first length plus the other side breadth, and then I take the length and I take the breadth. And of course, this will give us 2L plus 2B. Most of us have come across this before. So there's nothing special about perimeters of rectangles or what? Or rectangle, or perimeters of the parallelogram, or even that of the rectangle. We'll move straight and look at how to obtain the areas of each of these, most especially the parallelogram. Area of a parallelogram is simply base times height. And of course, you begin to wonder, in the case of a triangle, we said it was what? Half base times height. A parallelogram is twice a triangle, or you can call the triangle half of a parallelogram. That's why the area of a triangle is what? Is half base times height. Again, y for the rectangle is what? Length times breadth. Well, let's concentrate on our parallelogram first. The question now is, which of these sides will be the base and which will be the height? Am I going to take A as my base, or am I going to take B as my base? Should this serve as the base? Should this serve as the base? Or should this one serve as the base? Or should the other B serve as the base? Again, any one of these sides, either A or B, can serve as the base. The problem is, once you have chosen the base, the next thing is to do what? Get the corresponding height. So here I have on the screen, I said, just like in the case of the triangle, any one of the two adjacent sides, A or B, of the parallelogram can serve as its base. The issue again is, what will be the corresponding height for any of the chosen base? Let's see how this will come up. If I decide to take A as my base, what will be the height? How do I define the height of a parallelogram? Now, since I have taken A, this side here in red, that's the A, as my base, the height of the parallelogram is therefore the perpendicular distance between the opposite parallel side to that base. That is, if I can get this from here, there, the perpendicular distance between the two of them. You can also put it here, and here you want to put it. Just remember that the two sides are parallel. So once you have chosen your base, look out for the other side, which is parallel to it. The perpendicular distance between those two will serve as the height. So that's the height for this parallelogram, using A as our base. So that's it there. So if A is the base, that will be the height. What if B is our base? That is, if I use this other side here, the side in red, as my base, again, the height of the parallelogram will be the perpendicular distance between that base and its opposite parallel side. What am I trying to say? It means the distance from here, perpendicular. Be careful. This is perpendicular, 90 degrees. That will serve as a height in this case, which means the height depends on which of the sides is taken as the base. So that's it there. If the B is our height, sorry, B is our base, then the height will be as shown in the diagram. Also, there are situations where you will not be given the base and the height. Rather, you just have the base and you don't know the height. Instead, you'll be given one of the angles. It's either you are given this angle there. That's your theta. Or you are given this way. Whichever one you are given, all you have to do is what? Use your simple geometry and get the angle back there. How do I now get this height? If I have not given the height and the question provides me just this base, and also, or rather the question will provide you with A and B and will not give you the height, just like in the case of the triangle. Two adjacent sides are given and the included angle is also provided. Then, but you don't know the height. Again, we will apply our SOHCAHTOA there, and then we will obtain that our height will be B sine theta. Yes, because the height will be the opposite to that angle theta, and B will be the hypotenuse, since this is a right angle here. So I will have my sine theta is equal to the height divided by B. Cross multiplying, let's write it out. Sine theta will be what? The height, which is the opposite, all over the hypotenuse, which is B. So when we cross multiply there, 1 times height will give me this height, and then B sine times theta will give me B sine theta. So this will now replace my height. The same thing is applicable. Let's move a little bit. So you can see there, if I'm taking A as my base and I'm giving B, the height is not provided. What do? I simply use the theta that is provided to get my height. And then the area, of course, being base times height, will still remain A as a base, and the height will be B sine theta. You can see we have something very similar in the triangle where we had half AB sine theta. Here we just have AB sine theta. Similarly, what if it's B that we take as our base, and of course we are also provided with A? The same thing will happen. I'll simply come here and look at this. I say, okay, in this case, the height, without going into the rigor of our SOHCAHTOA, will be A sine theta. So that the area of the triangle will be what? Again, base times height. Sorry, area of the parallelogram. Base times height. And what is the base? The base in this case is B, and then our height is A sine theta, which of course you can still write as what? AB sine theta. So you can see, once you are given the two sides and the included angle for both of them, look at the one to the left and look at the one to the right. They are both the same. Just take the product of the two sides and multiply by the sine of the provided angle. So that's it there, A sine theta. So with that, we have come to the end of this video clip. We have been able to see how to obtain what? The perimeter of a parallelogram and a rectangle. And also that the area of a parallelogram is what? Is the length, sorry, the base times the height. And that the height is subject to the base. That the height of a parallelogram is the perpendicular distance between the parallel sides. If you pick one as your base, then the perpendicular distance between that side and The opposite parallel side will serve as your height. And in a situation where the height is not provided, but you are given the lengths of the two adjacent sides of the parallelogram and the included angle, then the area is simply the product of those two sides times the sine of the included angle. As we have always known right from when we're in nursery 1, nursery 2, the area of a rectangle remains length times breadth, so which means L times B. So we don't have to overflog this. We all know that the area of a rectangle will simply be what? The length times the breadth. Let's see application of these in the next video clip. I hope to see you there.